right, here we are, second part. We're going to start at 16. I'm trying to make the video small enough for you to be able to find the problems a lot more easily, and hopefully that is helpful. All right, we are on problem 16 when it's talking about what's not in the domain. So number 16, first thing is you have y is equal to log base 3 of x squared minus 9. And I want to know what's not in the domain. Well, in order to know what's not in the domain, I have to know the domain. If we go back to lesson 1 where we had y equals log base 3 of just plain old x, and we drew a picture of this, here was the log graph, right? And we said the y-axis is an asymptote because we can neither touch it nor cross it. Now that was just a plain old x. Now we have x squared plus 9. Well, with this plain old x and the y, we then said x has to be greater than 0 because that would be the name of the y-axis. That's the line x equals 0. We have to be greater than that. We have to be to the right. So now if I want the domain of this guy, I have more than x. I have x squared minus 9 has to be greater than 0. And I can factor this. I can use dots and have x plus 3, x minus 3 if I wanted to. And then I have to say, oh wait, this brings me back to chapter 5 with conjunction and disjunction. And so you can solve and get x equals negative 3 and x equals positive 3. And then you can make the graph and you can say, okay, what's going on? And you can check numbers, like you could take 0 and you can plug it in. If x was 0, and you would check and say, all right, what is 0 squared minus 9? Is this greater than 0? Negative 9 greater than 0, this is false. So you could say, all right, let me try back here. Let me check negative 5, let's say. And negative 5 squared minus 9, is this greater than 0? Well, that's 25. Minus 9, you get 16 is greater than 0. This is true. And you can check back here at 5. And 5 would actually end up giving you the same thing, because you would have 5 squared minus 9, even though it's positive 5 now, it's still 25 minus 9, you get 16. Which means this became a conjunction. This guy was looking like this, and this side was looking like this, because this exponent gave me more than 1. And we've seen this with exponents before. So now they're saying to me, which one is not in the domain? And the choice would be 2 is not in the domain, because 2 would be right here. He's clearly not in the domain, and that was choice 2. Now that was a lot of work for multiple choice. Now, granted, if I were you and I had a graphing calculator, I would have absolutely gone to y equal, and I would have used the math A log base, and I would have typed in the problem. And then I would have hit graph, and I would have said, oh, look it, 2 isn't in the domain because here's 2, just like my handwritten graph. Now, so again, on a test I would use the calculator, but I always do want you to understand why certain things are happening. That's just, you know, the way my brain works. Next one, number 18. If log base 2 of x equals a, then the expression. So this is substitution. This was on lesson 3. So let me use a different color so they don't overlap. All right, so number 18. We're going to have some substitution. 18 says a is equal to log base 2 of x. And now I have log base 2 of 8x to the 6th. Well, I need to use my log rules right here. multiplication. This is product. And here, this is power. So this would give me log base 2 of 8 plus log base 2 of x to the 6th. But the power, I have to figure out. But this is a number. These are all numbers. The log of 8 divided by the log of 2 is actually going to give me 3 because 2 to the 3rd equals 8. So again, that's bringing us back now to lesson 1. So you had to, when it's all numbers, you have to figure it out. And this would then be plus 6 times the log base 2 of x. Well, now I'm going to substitute. They said log base 2 of x is a. So this would be 3 plus 6a. And that would be, then they factored it. So choice 3, they factored out the 3. And that would be 1 plus 2a. And they then use commutative and have 3, 2a plus 1. Either way you look at it is choice 3. They really took this to a high level. This one was a challenge. We did see these in lesson 3, so just be wary. Take your time. Remember, substitution comes last. We don't substitute first. Substitution comes last. Well, all right, so now, I think I moved that when I was erasing because it takes, there we go, let's see, is that better? Okay, all right, so now we're on 20. Assuming x is not negative 2, which of the following is the same? Well, again, here's log laws again, so this is lesson 3 again. So number 20 says log, and it's a common log because there's no base, x squared minus 4 minus log 2x minus 4. Well, this is the quotient rule. So if I factor out these logs like we did, I would have x squared minus 4 over 2x minus 4. Well, I can simplify this fraction. So, chapter 3 fractions and chapter 1 factoring. This is dots, and this is GCF. So if I factor, I have the log now of x plus 2, x minus 2, over 2 times x minus 2. These guys cancel, so this simplifies to the log of x plus 2 over 2. I cannot reduce the 2's. If you remember going back to when we did this, polynomial, monomial, you're not the same. You cannot be reduced any further, so this one is also choice 3. If I remember, there were a lot of choice 3's yesterday too. All right, 22. For what value of k will this equation be satisfied? I have the log base 2 of 4k. And minus log base 2 of 3 equals 5. So now what this is the quotient rule, and I'm going to use the quotient rule again. And I'm going to factor out the log base 2, and I'm going to have 4k divided by 3 is equal to 5. So that was lesson 3, quotient rule. Now what I'm going to do is go back to lesson 1. 5 is the exponent on a base of 2. So 5 is the exponent on a base of 2 and the power 4k divided by 3. Now, 2 to the 5th is 32. We've seen that so many times. Some of you have it memorized. So 32 is equal to 4k over 3. I want to cancel division. I'm going to multiply both sides by 3. And now I have 96 is equal to 4k. Divide by 4. And k is equal to 24. And 24 was choice 4. Now, again, with the calculator, you could have absolutely just kept plugging in each number and typing it in and using the log base under the Math A on a graphing calculator, or plugging in each value. So like, say you did 24, you would have said 4 times 24, 96. The log of 96 divided by the log of 2, enter, get an answer. Log of 3 divided by the log of 2, enter, get an answer, subtract them. You'd have gotten 5. So you could have done it either way. All right, so now I am up to 24, which is solving to the nearest hundredth. This was lesson 5, lesson 4 and lesson 5. I think they're telling me to use the common log though, so let me just take a fast look when I'm done erasing. But we're solving to the nearest hundredth, I believe it said. So let's take a look. So, oh, they didn't tell me which kind of log to use. I can use any kind of log. I'll actually use the common log this time because I think maybe that if you see that on some of the videos from the author, I don't want you too confused. Solving to the nearest hundredth, I have to divide by 8. And I get 2 to the x is equal to 5. You can't write 5 as a base of 2. So if you put a log on both sides, you get x times the log of 2 with the power rule is equal to the log of 5. So even if you use natural log, you're going to get the exact same answer. That's the nature of logs. Divide by the log of 2. And you are going to get x is 2.321, and it goes on. They said to the nearest hundredth, I believe. Yes, so hundredth means I'm looking at this 1, and I get 2.32 for x. And so choice 3. 26 for the real number e, which is true. Well, 26, when we did this and you typed e on your calculator, remember it always gives you an exponent. And when you type it in, e is 2.71828, and it goes on. It's irrational, so what is true? Choice 2. E is greater than 2, but it is less than 3, so it is choice 2. 28, which of the following represents the value? All right, let's take a look at 28. Which of the following represents the value of the natural log of the 8th root of e to the b power? Well, this is combining lesson 3, log laws, with lesson 4, the number e and the natural log. Remember, the number e and the natural log are inverses. And with exponent laws, this is the index. This is the exponent. So therefore, this guy becomes natural log of e to the b over a power, because the exponent stays the exponent from our log laws and from chapter 7, fractional exponents. This is the index. These guys are inverses. They cancel each other out, and he just drops down. So we get b over a. And so that was choice 2. Number 30. they want you to make a graph of this over -5 to 5. So when you are given a strict domain, that is exactly what we would have to see on the long answer part. So if I give you a problem like this and I say, make me this graph from -5 to 5, guys, I am going to see a table, and let's first write the equations. This is number 30. Y is equal to 15 times 0.75 to the x, and they say -5 to 5. That means here's my table. And I'm starting it at -5 and I'm going up to 5. So, of course, I'm going to want to use my calculator. I mean, you could type -5 in. Like, if you don't have a graphing calculator, you can't tell me you can't do the work. You just have to take longer. You have to put 15 times 0.75 raised up to the -5th power. Okay? That gives me 63.209, so I'll put 0.21. Then you have to type in 15 times 0.75 raised up to the -4th power. And -4 gives me 47.41. And so you have to do that for all of these. Oops. Now, 0 is going to give me 15. I know that because anything to the 0 power. And then you have to continue on. And if I have 15 times 0.75 raised up to the 5th, I am at 3.56. So we're going down. And again, you would have to make this entire chart for yourself. But here's the thing. If I'm graphing this, -5, 5, and I have at 0, 15. So let's go, and we have to go up to 65. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. Remember, you have to scale your graph appropriately, and if you don't scale appropriately on a question like this, it's marked wrong. So -5 is up here at 63.2. Now this is where you're estimating to be as close as you can. That's in between 60 and 65. So there's my 62. My -4 is at 47. That's a little bit above. Went out a little too far. There we go. And my 0 is at 15. My 5 is at 3.56, so I'm lower. And so, of course, you would plot all your points. I just don't want to waste too much time on the video, but there you go. Scaling matters. So if we give you a problem like this, it matters that you pay attention to the domain. This is so important. This better match your table. And then, of course, you would fill in. Now, again, if you don't have a graphing calculator, then you just have to type them in one at a time. The calculator does all the hard work. So don't not do the work because you don't want to type it in. Okay, so let's do number 32 and 34. 32 is a nice one. 32 is going back to chapter 7. These ones are very nice. You have 8 to the 2x minus 1 is equal to 16 to the x plus 1. Here's an 8. Give me change. You're going to give me 2 to the 3rd and 2x minus 1. Here's 16. Well, if 8 is 2 to the 3rd, 16 comes from 8 times 2, so it's 2 to the 4th. X plus 1. Everything's equal, bases match, exponents are equal. So distribute. I get 6x minus 3 is equal to 4x plus 4. I'm going to minus 4x from both sides. I'm going to add 3 to both sides. And I am going to get 7 and divide by 2, I get 7/2, which is quite fine. That is a fine number, nothing wrong with that. You could give me 3.5 because the decimal terminates, but you don't have to. 34. Ashmore population has a population that is steadily decreasing 6% per year. So we're on 34 now. My rate is decreasing 6%. My time is the year. Again, I'm not going to be a fraction because they didn't tell me any compounding, and they didn't tell me that it takes 5 years to decrease 6%. So they didn't give me any condition. They just said 6% per year. So again, that tells me amount over time is equal to the initial amount, the rate, 1 minus the rate to the time. Okay, I wrote that too fast. And so in 2000, so time 0 is 2000, the population was 7,500. So the initial amount was 7,500. And this is in the year 2000. So year 2000 equals time 0. This is where we're starting from. And they want to know how many people we should have in 20 years. So now they're actually giving me 20 years. So basically we're asking what's the population now in 2020. So in 2020, that's our answer. So let's figure this out. The amount of people in 20 years started with 7,500, and 1 minus 6% would be 94% is what we kept, and we're doing this for 20 years. I don't even need a log on this problem. This one's a straight plug-in. 7,500 times 0.94 raised up to the 20th, and I get that there should be 2,175.7968 people. Now you can't have a piece of a person, so this would be 2,176 people. How did they, oh, yep, nearest integer they said, because you can't have a piece of a person. So I'm going to stop this video here. I think, 15 to 20 minute long videos is enough. And then I'm going to pick up 36 on the next video, and I'll finish the packet then. Good luck.